All right, good evening, and I hope that you are well. Thank you for coming in to this class. This is for Group B, but we also say that everyone can join. Want to start a business with $100? Just checking something here on the audio to see whether the audio is okay. You could also get some confirmation on the chat section. If you can hear me clearly, maybe one of you could comment. Well, good. Yeah, I've confirmed. Audio is good on my side. Thank you. Thank you for those who have joined on time. We are going to move a little bit quick because this is an introduction, the first session. For Group B members, you need to register your attendance. Just type your name and registration number so that we can take class attendance. Now, if you have any comment or question as we go on, you could chat it there. As well as towards the end of the lecture, I'm going to share the live link where you can also ask me a question if you have any. So I'm going to exit this screen so that I can go to where I can make it full screen. Okay. So right now I'm not seeing, of course, I'm monitoring using the phone, but I'm not seeing much on what you're doing there. But the live chat is quite clear on my side. Yeah, as you all know, is that of course you came to do civil engineering, and as I was explaining in the morning, is that engineering construction used to be two parts: civil and military. Civil means the ordinary mwananchi, or we talk of the civil people, not the military, because initially, when this field was in formative stages, usually there was a lot of construction of bridges and they were being done by military engineers. So in civil engineering, now we are talking of structures which are not non-military structures, roads, bridges for common use by citizenry. And in so doing, when you talk of civil engineering structures, we know that we construct them using some materials. And the most common material that is used is concrete. Okay. Of course, we can have structures made of steel, made of timber, and some emerging materials like polymer, but concrete remains to be one of the highly or the most utilized materials in construction. According to, let's say, could I say, 2013, some publication by World Bank, concrete was recorded as the second most consumed material after water. Okay, so you can imagine the consumption of concrete worldwide. Concrete is second to water. So it tells you the significance of concrete and the need for us to understand concrete. Of course, concrete is an old material, but we continue improving in the technology, the application. So in this course, it's a two-part series. We have the civil engineering materials 1, and then next semester we'll have civil engineering materials 2. In materials 1, we are going to look at concrete as well as masonry. When you talk of masonry, we are talking of the building stones and building blocks and plaster and all that. Now, in the civil engineering materials 2, next semester, we are going to look at steel, timber, and polymers. Okay. Now, those are just my details. The purpose for this course is to provide you with an understanding of concrete, how you can conduct tests, and especially quality control. Because unlike steel, steel is produced in a controlled environment in the factory. For concrete, and concrete for your understanding is a combination of cement, which is the binder, and then we have, in layman's language, we say sand, or in common language, we say sand and ballast. But you're going to realize in engineering terms, we talk of sand as fine aggregate, and ballast as coarse aggregate. Okay, so you see, concrete in itself is a composite material. It's composed of different materials. Now, we need to understand quality control is very key, because this is something usually concrete is produced on site. And not everyone is an expert in concrete. Some people handle concrete out of experience. You see, you encounter a mason, a fundi, and he says, we have been doing this for so long. Okay, maybe he had just been exposed to masonettes, small buildings, and so on. But now you are talking of maybe a high-rise building, but he still won't use the concrete the way he knew about, or the way he have understood through experience. And that's why you find like it is not the only cause of collapse of buildings in Kenya, but material quality control is one of the major problems. Of course, there are other issues like foundation, okay, settlement, and so on, but quality control. You realize that you have both good quality, good side, you have good ballast, you have water that you are using is okay, the ratios are okay, but maybe during the mixing, the quality control, maybe the ratios, something happened, too much water was utilized, so that the end product, you do not get to attain the strength that you required. So you who is being trained to become a future engineer, you are the one to give direction in future insight. So you are the one now to provide a direction. And for that, you need to have a proper understanding of concrete and how to conduct different tests that will be able to check whether your concrete have attained the required strength. Of course, we are also going to have part 2 on masonry and how to do the various tests. And as I say, at this stage, just know that masonry, we are talking of the building blocks, the building stones, you know, the mortar, and so on and so forth. So this is the course content. Of course, in this page, I've given it in a structured manner. So we are going to first understand, because the composition of concrete is said is a composite material. So when we want to produce concrete, we need to have a binder. Okay. In our case here is cement. And why do I say binder? This will encompass other materials, because currently we have new and upcoming type of concrete which do not use cement. One of them is what we call geopolymer concrete. It doesn't use cement, but it uses geopolymer material. But for our case here, for our class, we are learning about cement. So concrete will have cement, will have fine aggregate, which I said this is an engineering term. On site, maybe you'll be talking of sand, and then coarse aggregate, which of course is referred to as ballast. So going forward, you may find like we are not utilizing these terms so much, but we are referring to the standard engineering terms, the fine aggregate and the coarse aggregate. And of course, we have the water. Okay. Now, just hold on there. Allow me to exit briefly. These days, Nairobi is becoming something else altogether. Then let me shift to good. We are connected. We are okay. And I trust also on your side, you're okay. Okay. All right. Good. Okay. Now I can come back full screen again. Now we are saying that cement, concrete, cement, fine aggregate, coarse aggregate, right? Now, so the first thing that we need to understand is about cement, how it works, okay? Then we understand about fine aggregate, then we understand about the coarse aggregate. And of course, we need to know the quality of water that we need to use. That's why you have, see, I have itemized this component of cement, of concrete, in terms of, we start with understanding the cement, how it's manufactured, the different types of cement, the chemistry of cement, okay? As you are going to see, and this lecture, you're going to see a number of chemical equations, okay? Because the hardening of cement, when you form concrete, is a chemical reaction. It's not a physical reaction. It's not like the way you can mix water with soil to create mud, and then it hardens. so that later on you can come and pour water on the soil, and then you can be able to get the same mark. But for cement, when it have hardened into that hard lump, it's a chemical reaction that have occurred and it's irreversible. So you need to understand about those chemistry, then the properties of different types of cement, and how to assess the quality of cement. Then we are going to learn about the aggregates. Of course, again, types, classification, okay? And we said when you talk of aggregate, we are referring to both the fine aggregate, where sand falls into that category, and the coarse aggregate, where you have the ballast. Now, concrete, of course, we are going to end up with different types of concrete based on how we are going to mix these ingredients, the cement, the fine aggregate, and the coarse aggregate. And of course, the type of cement that we use, we are going to see the different types of cement, how the properties of concrete, and how to conduct tests on fresh and hardened concrete. Fresh is concrete that is still in plastic state, okay? It have not hardened, it's not rigid. You see, you need concrete which you can be able to mix effectively, transport it to where you are going to do your casting, place your concrete, and you vibrate it well. So you need a concrete in its fresh state having some properties. And one of them we say is the workability, a workable concrete. Again, when it have hardened, we need to get a concrete of some certain aspects, attributes. For example, the compressive strength should attain to some value, okay? The durability, the water absorption, and so on and so forth. Then we are going to do concrete mix design, how to design concrete mixes. And then batching. Batching is how you do you measure, how you weigh the different, ingredients. How do you weigh cement? How do you measure fine aggregate, coarse aggregate? Is it by volume? Is it by weight? Then mixing procedures, how to transport, because in mixing, transporting, placing, compacting, and curing, even though you might have used, in either of these stages, you can mess up the quality of your concrete. You bought expensive cement, you have good quality aggregate, but in the way you are measuring them, you are batching, the way you are mixing them, the way you are transporting, like you may transport, and then you find like there is segregation, there is separation of coarse aggregate from the cement slurry, okay? So even in transportation, and I hope now you have seen these trucks which carry ready-mix concrete. These trucks, for example, you have one called Alliance Concrete. You see them on the road. They are huge trucks, and then they are rotating. So it's not something like the rotation of that drum that is carrying some concrete is to maintain, the homogeneity of the mix. So transporting is very key. Placing, you see, if you throw concrete like the way we throw sand, like when we are loading it on a lorry, it's again going to segregate. So you had a very good mix, but then if you throw it over a certain distance, beyond a certain distance, you may feel like segregation may occur. And segregation is not only for aggregate, but it's also water. You may feel like water is coming on the surface, okay, leaving inadequate water for chemical reaction to take place. And we are also going to see the different quality control tests that you can do on concrete. Finally, we are going to look at masonry. We see the different types of masonry, their property, use, deterioration, and then mixes of mortar. So when you talk of masonry, think about a wall, okay? So a wall like this, okay? We're going to look at this. So in between the joining here, we use mortar, okay? And mortar, this is the fine aggregate plus cement. So you see, we learned about the fine aggregate here in this in the area sections. So that's why now we are learning, we are coming to prepare the mortar. And then what is the usage of this mortar? Mortar is used as a bedding material or laying to be able to board this masonry unit. So we cannot study just about mortar and then leave about the quality of these building blocks. It could be blocks, concrete blocks. They could be building stones like the Darugo stones. They could be even earth blocks, okay? So that's why I'm trying to create a connection between why we are talking of concrete technology and then we included masonry. It's because we learn of mortar and the application of mortar is in bedding. Of course, mortar is also used in plaster works. Now, at the end of this course, of course, there are things you need to know, the various methods of cement manufacture, the different ingredients of concrete, and the many tests that we do to ascertain the quality. Again, you should be able to do concrete mix design. Let me mention something here. There is something we call the nominal mix, okay? Nominal mix. From the mini test, because concrete is an old material, ordinary concrete, from the mini test, we know to attain a certain strength of concrete, there is a certain ratio that we can use, okay? Let me give you the common classes of concrete. We have class 15, we have class 20, we have class 25, we have class 30. So these are ordinary strength concrete. However, these two are not structural. These are non-structural. By non-structural, we say this concrete is not used in casting or in creating or in building structural elements like a beam or a column or a slab, okay? Class 20 used to be structural, but nowadays we no longer consider it to be structural. But now when we want to construct those beams, those columns, the foundation, these are the classes that we consider. Now, normally, it's known that class 15, the ratio is 1, 3, 6. This is cement, fine aggregate, coarse aggregate, okay? Then for class 20 is 1, 2, 4. For class 25, the nominal ratio, the nominal mix is 1, 1.5 is 2, 3. And then finally class 30 is 1, 1, 2. So for every kilo of cement, you add a kilo of fine aggregate and 2 kilos of coarse aggregate. However, when you do this, you do not have to do any design. You just take the materials you have, you use this ratio. But your materials vary, or materials vary from site to site. And these nominal mix have been found through experiment. And usually, because we borrowed so much from the British standards, these are tests that were done, or we adopt them from British, okay? So in our case, you find like our aggregates, our sand in UK is different from sand in Kenya, okay? So therefore, it means we may need to, out of the properties that we have determined of the aggregate, we may need to get the exact ratio for our concrete. And that's why we do concrete mix design. You may find like to attain class 30, using some aggregates from maybe Machakos, maybe you have to go with, you may have to go with, instead of 1, 1, 2, you may have to go with 1. Maybe you have very good aggregate. So you may have to, you can increase 1, 1.5, maybe 2.5, and it's able to attain this. So you see, in that case, you have been able to minimize or to economize because you are using less cement and more of the coarse aggregate and fine aggregate to achieve the same strength. You may go somewhere like in the Rift Valley, you find like your aggregate is like pumice, the lightweight. So it's not very strong. Therefore, it requires for you to attain the same strength, C30, you may need to use lesser of this fine aggregate and higher of cement. So you may need to go with the 0.9 is to maybe 1.8. Okay. I believe somebody, now that you know mathematics of ratios, should not be something to worry you. You should be able to see when I reduce this, then it means the cement content is higher as opposed to here. Now, another thing that you need to note is that when you say of cement class C15, we are saying that the strength at 28 days is 15. So for class 15 is 15 MPa. What is MPa? Newtons per millimeter squared. So for class 20, again, for class 20, again, my laptop now power is almost going off. Don't know what we need to do here. Now, for class 20, again, is 20 MPa. Class 25, 25 Newton per millimeter squared. So we need to understand all this to be able to conduct the concrete mix design. Again, you need to understand at the end of this, the various stages of concrete production and relevant test on each of the stage. So of course, the others, you can see what you are required of you. So of course, the teaching methodology that we adopt, we know, is that we'll have lectures, we combine physical and online. Of course, we are going to see how we go about it. Then tutorials, laboratory work, and this is a key. This course is highly experimental. So you are going to spend a significant portion of your time in the lab. Of course, you'll be guided by the lab technician. Our work will be conducted in structures lab. I don't know whether you remember. This must have been done to you during the orientation in first year. Our structures lab is just near the workshops. Of course, we may have other presentations as we may deem necessary. So this is the assessment. Nothing has changed. That the written exam will constitute 70%. Continuous assessment, that CAT is 30%, whereby the CAT is, oh, this is different. Huh? Laboratory practicals 10%, CAT 15%. It's the other way around because you're going to have assignments. So you have the CAT is 10%, assignment 5%, and laboratory practicals 15%. Yeah, I've corrected that. Okay. Then these are some of the practicals that you're going to do in the lab. Okay. And again, I've broken them down in terms of the different, I can say, elements of concrete. That is, we have cement. So cement, we have 3 tests that we are going to conduct on cement. Let me not go into details about this because even if I tell you consistency of cement, setting time, soundness, if we have not learned them now, you might not understand what we are saying. But you see, we have 3 tests here. Then for the aggregate, we have test 4 to 9. For fresh concrete, we have 3 tests, and so on. Now, if you look at this, we are limited with resources and time. Right now, if you go to our structures lab, it's being used by master student, PhD students from Pausti and JQuat. It's being used by our 5th year students. So it's overcrowded. So you might not be able to conduct all of these tests, and you might be overwhelming the technicians. So what we do is, there are those tests that you can do demonstration on, okay? But the ones I have said submit report, we have 6 reports, okay? These ones you have to submit for examination. You have to conduct these tests for purposes of examination. So I hope that is very clear on your side. In terms of the assignment, we have 1 assignment. After you have done the test in the previous slide, you're going to get the properties of different materials, the properties of fine aggregates, the properties of coarse aggregate. We are going to use that data to be able to design the concrete that you are going to use. So you arrange yourselves in groups not exceeding 6 people. So I don't know how many you are for now, because we are meeting for the first time together today. So, but make sure the group do not exceed 6. Why? Because you have 6 practicals, and I expect each one of you to contribute. So I expect that 1 practical is written by 1 person, but it's, of course, it's a representative of the group. Then you submit it together, bound in one document. You have 6 practicals and then 1 assignment put together. Okay. Now, in those groups, you're going to work, and then you design. Members, you need to agree on what class of concrete you need to design. And you are going to choose from class 20, class 25, class 30. The cement and all the materials that you require, you are catered for in the lab. So you are not buying anything. You don't have anything to do with the budget, okay? And then we are saying all the practical reports and assignment must be handed in by the 14th week of the semester. You know, 15 and 16 weeks are for exams, eh? So the last Friday before you do exam, that's when usually I want all the practicals to be handed in. If they can come early before that time, well and good. But at least they should not exceed that. We have a number of references, but the first one is one of the most detailed and very easy book to learn. And I know we have a number of copies in our library, so you can borrow this. Of course, it doesn't have to be 2011. Neville have written different editions. This is the 5th edition. Even if you get the 1st edition, still you're going to get some good information of the same. Okay, so get these books and utilize them to have. Now, reference number 4 on design of normal concrete mixes. This is a manual. I would like to draw your attention that as you are being trained to become engineers, later on when you graduate, you're going to have a library of manuals, because in design, we always refer to manuals. So you can utilize this time as this BRE manual. This manual has been your first you graduate. So make sure it's not a very big document. I've shared it with your class rep. I hope you have shared the note with you also. So print that, make it a bound copy for future references. Of course, now giving a disclaimer that because much of the lab work is understood through experiment, so the laboratory test in the notes that I'm giving is just a brief theoretical description, okay? But you should follow a step-by-step procedure that will be given in the laboratory manual or as guided by the technician, okay? Now, unfortunately, as I'm telling you on my side, we like to cut short this class because my laptop is not fully charged and power have gone off. Let me see how much is remaining. And I don't want to start. Yeah, it's almost going off. So instead of starting something and then in the next 3 minutes it's cut short, we can create another time we continue. But I would like to thank you, all of you, because of joining on these late hours. And apologize because of that inevitable happening. Of course, you are going to get time to be able to learn all about this. So thank you for, you can see even people have registered their attendance. Make sure before you leave, you register your attendance. We are going to communicate the next time we are going to have a makeup for this class. Okay, because next week we are going to go to lesson 2. So this one you have to fight time. We have a makeup. So tomorrow I'll be there physically. I don't know whether you can have time, but if not, then we can still finalize it online. We are going to communicate via class reps and agree, and then we see when next we can complete what we have started. Yeah, now the laptop is done. Bye-bye. Stima imenisumbua bwana.